Pa?
Pwede
Ayun
na
na.
po. Pwede na po.
Salamat. Long time no look. Joke, joke. So, yung midterm natin comprises of mga um, methods of analysis sa mga network theorems natin, no? Katulad nung nodal, mesh, superposition, Thevenin's at Norton's, no? So yun ang coverage ng midterm. Kasi in-scan ko kanina nga, nakita ko yun yung coverage ng midterm natin, itong 5 networks na to. Tapos after these 5 networks na to, techniques na to, finals na, no? Pakita ko man sa inyo, no? Lesson 5 to, di ba? Tapos tiningnan ko yung pinakadulo niya, lesson 6 na. Yung lesson 6, steady state power. So ibig sabihin, yung midterm natin na comprises of this technique, yung paggamit ng nodal, mesh, super, position, Thevenin's at saka Norton's. So tapos nakita ko yung pinakahuli dito, yung exercises. Sabi niya may mga lima kayong exercises dito. Ay, 4 lang pala. 4 lang. So dito sa 4 na exercises na to, pinapagamit sa inyo yung lahat ng network, no, yung halimbawa nodal network, mesh analysis network. So yung mga network na to, no, 5. So bawat isa isosolve ninyo. So ibig sabihin, kailangan muna nating tapusin lahat itong mga networks na to sa paggamit nitong mga technique na to para magawa ninyo yung mga activity ninyo. So siguro ang gagawin ko, itong number 1, halimbawa, sabihin ko, ito yung activity 5 na ba kayo nun? 5, tapos ito 6, tapos yung isa 7. Tapos siguro yung isa, pero titingnan ko, ito yung magsisilbi sigurong quiz number 2 ninyo. So tingnan na lang natin, no, para dito na lang natin kunin lahat yung kailangan. Okay. Tapos, siguro, mga by next week matatapos natin yung discussion na to kasi dun sa nauna kong klase na-discuss namin mismo yung tatlong technique. Tapos yung remaining 2 siguro next week na yon. Tapos na tayo noon. So ang gagawin lang na natin noon, iseset na lang natin yung mga schedules para sa mga activity ba, 5 na ba, 5, 6, 7, as well as yung quiz number 2 nyo. Then after that, midterm na noon. No? So, ganun kadali yung kung titingnan natin yung diskarte ng midterm coverage natin. Okay, so continue na natin. So mag-start na tayo sa discussion. So yung unang i-discuss natin dito yung say nodal analysis, no? May binigay na objective dito, no? Parang yung objective na to parang same doon sa DC circuit din nakita ko no? Tapos may mga steps lang dito. So yung mga step na dito habang ginagawa natin solution, actually sinusundan natin yung mga step na to. So diretso na tayo siguro dito sa circuit natin using this nodal analysis. Sabi niya, nodal analysis and application of KCL, Kirchhoff's current law. Of course, applicable din also dito yung KCL, even though na itong KCL natin under, itong pinag-usapan natin is under AC circuit. So we can also apply this KCL here. It doesn't mean then na yung KCL is only for DC circuit. No. You can also use this in AC circuit. Okay? So this our given circuit. So in our given circuit here, we are required to determine the voltage across the 4 ohm resistor as well as across the 8 ohm resistor. Actually, there are 2 8 ohm resistor here. Itong 8 above this 4 ohm and another 8 dito sa right side ng circuit natin. But nung in-scan ko yung solution niya dito, nakita ko ang required resistor is this resistor here, not the other one here. We're looking for the voltage across actually this 8 ohm resistor that's connected in the right side of our circuit, not in the upper part of our 4 ohm resistor. Meaning we are looking for the voltage across this 4 ohm resistor as well as this 8 ohm resistor here. So our for the solution, we have this given omega. Our omega here is 4. So knowing now that our omega is 4 here, then we can now say convert this possible elements, say inductor here 1 Henry, another 1 Henry here. At the same time, we have 1/8 farad here for our capacitor. So for us to convert this 1 Henry into its corresponding impedance, so we can use the formula J omega L for the inductor. J omega L. Omega is 4, L is 1 for this inductor. So meaning the impedance of our 1H here is J, positive J4 ohm. While for this 1/8 farad capacitor, its corresponding impedance, say sub C or X sub C, is equal to negative J omega C. Omega again is 4 multiplied by C 1/8, meaning our Z sub C equal to negative J 2 ohms. No? So of course, the impedance of 4, 8, and another 8, there will remain the same, meaning Z sub 4 is 4, Z sub 8 is 8, Z sub 8 is 8 ohms, like that. No? Then after that, the next step then is to label its node here, and then at the same time, we need to select our reference node here. Let's say, for example, this our node 1, here. Let's represent this as node 1. Ito naman, node 2, node 2. Tapos this one, node 3, node 3. And we select this bottom part node as our reference node. Meaning to say, sabi natin, yung reference node voltage natin here is 0. Isn't it? No, yung voltage natin dito sa reference node natin is 0. Okay. Of course, by inspection, we can simply say that the voltage across this 4 ohm resistor is V2. Actually, we are looking for the voltage across this 4 ohm and at the same time the voltage across this 8 ohm resistor. Meaning to say, by inspection, the voltage across the 4 ohm resistor is V2, while the voltage across this 8 ohm resistor is V3 with respect to our reference. Okay. Okay, so nag-apply siya ng KCL dito sa supernode. Gumamit siya ng supernode because we can use supernode here because we have source voltage here wherein there's no element in series with this 2 angle 0 volt here. There's no resistor in series with it, or say inductor, or say capacitor. So that means we can use these two nodes connected to the corresponding terminal of our 2 angle 0 here as our supernode here, because there is no element connected in series with it with respect to B2 and B3. So therefore, we can use supernode at B2 and B3. Okay. While now KCL at the supernode, starting from node 2. So what are the elements connected to node 2? Actually, we have 3, the 8, 4, and positive J4. So starting from the 8, so we have a current through this 8 ohms, say equal to B2 minus B1/8, isn't it? B2 minus B1/8 current through this 8. Next, followed by the current here in the 4 plus B2/4, current through this J4 plus B2/J4. So there are no other elements connected to B2, so we can now transfer to B3. So for B3, we have how many elements connected to it? Aside from this source voltage here, we have positive J4 there, negative J2, and positive 8 ohm here. Starting from this J4, so we'll have B3 minus B1 over J4, then followed by this element connected to B3 also. So we have plus B3 over negative J2. Then the last one, we have B3 plus B3 over 8 equal to 0. So wala ng elements connected to B3, so we're gonna equate it to 0. Then after that, we try to arrange this equation. So we factor out, or we combine all the voltage B2 and separate it to B3. So this is how we represent the voltage B2 and the voltage B sub 3, including B sub 1. You notice voltage B1 over 8 and B1 over J4 are transferred to the right side of our equation. Why? Because try to inspect our circuit, we'll notice by inspection that our B1 with respect to our reference is equal to 6 angle 0. So meaning we can simply substitute the value of our B1 here, which is equal to 6 angle 0 in our equation here. So that's why the solution here is like this. The voltage V1 was already transferred to the right side of the equation since the value of the voltage is known there. No value of voltage V1 there. That's why it's already transferred. The Y1 was already transferred to the right side of the equation. Okay, so if you do that, then we can substitute the value of our B1 there. B1 equal to 6 angle 0, diba, here. So this now the corresponding new equation from our equation 1. So we'll have V2 times 3 over 8 minus J 1 over 4 becomes negative J because of this 1 over J4 here. That's why the corresponding value then, if we rearrange it or say simplify it, we get negative J1 4, isn't it? Then plus 4B3, this one, B3 times 1, 8 plus J, 1 over 4. Then for the right side, we substitute that, say 6 angle 0 multiplied by that. Now, further simplifying, then we have this what we call, say, equation 2 from equation 1 after we substitute the value of B1. And at the same time, try to inspect this equation 2. We have, this time we have 2 unknowns from 3 unknowns in equation 1. While when we substitute B1, say equal to 6 angle 0, we notice then that we have now only 2 unknown known nodal voltage, say B2 and B3. So meaning we need one more equation for us to solve, say, B2 or B3. Okay. One way to solve our B2 and B3 is, say, by considering KBL at the supernode B2 and B3. We can use supernode, isn't it? We can use supernode here because there's no element in series with 2 angle 0 here. So we can use this as our supernode. From the supernode, we can simply say here that our equation 2 angle 0 equal to B2 minus B3. While B2 minus B3, because the positive sign of our 2 angle 0 is connected to B. So by inspection, 2 angle 0 is B2 minus B3 equal to B2 minus B3, not B3 minus B2, because of this positive sign of our 2 angle 0 connected near to B2. That's why by inspection, we mentioned here that from the supernode, B2 minus B3 equal to 2 angle 0 degree. So once we determine this equation at the supernode, then we can now use, say, what we call matrix equation form. Following that matrix equation form, pwede nating isolve kaagad yung B sub 2. Actually, matrix equation form is like this. We notice that our equation is arranged from B2 to B3. So we can form a matrix equation here in this form. Okay, we have the two unknowns. We have B2 and B3, it's arranged from left to right, B2 and B3. So in vertical form here, we have to write B2, B3. Then for the first column of our matrix equation form, we have to consider the coefficient of our B2 there. So let's say 3, 8 minus J 1/4. Then for equation 2, the coefficient of B2 is 1. Then for the second columns, again, from equation 2, the coefficient of B3, we have to write down here 1, 8 plus J 1/4, 1/4, I mean. Then the coefficient of B3 here is -1. Okay. Then after that, we can equate this to this constant, a 3/4 minus J 3/2. And next we have 2 angle 0 degree. So this is how we form the matrix equation from the two equation here. So once we form the matrix equation, so we can simply say that our B2 here is equal to this numerator over this determinants. The determinants comes from here. No? So the determinants is equal to this. And for the numerator, so we have to substitute this constant with respect to the first column since we are looking for B2, B2, B3, B2, B3. So first column is for B2 here, right? Since we are looking for B2, so we have to substitute this constant with respect to the first column, the numerator of our numerator here. So in second column, will remain the same here, just like this. No? Then after that, we can now simplify this by considering these two arrows here. Downward arrow is for positive, then upward arrow is for negative. Downward arrow here again is for positive, then upward arrow here is for negative. So we have to take the product of each arrow here. No? So starting from the numerators, this one multiplied by that to this. So minus the product of this, ayun siya. Then for the denominator, multiply this product. Multiply this element here, the product of this element here. Okay, ito siya. Then minus the product there. Ito siya. Then after that, simplify natin, we'll get this one. 2 angle and 2 minus J2, I mean, in rectangular form. So after that, we try to convert it to polar form, the corresponding polar form expression of this 2 minus J2 is 2.83 angle, -45 degrees. Na? So once we determine this B sub 2, maybe we can substitute that B2 here for us to determine our B3. And we find out that our B3 in polar form is 2 angle 90 degrees. By inspection, we try to go back to our circuit. Actually, I already mentioned it already that the voltage B2 is also the voltage across 4 ohms, and B3 is also the voltage across the right ohm resistor, 8 ohm resistor. So meaning to say, since we already computed our B2 from complex to steady state, so we can simply say that our B4 ohms now is equal to 2.83 cosine 40 minus 45 degrees, while our voltage across 8 ohm resistor from B3 here, since we know that B3 is equal to 4 across 8 ohm resistor, we can simply say then that the corresponding instantaneous voltage across that 8 ohm resistor is 2 cosine 40 from this vector expression of B3, 2 cosine 40 minus 90 degrees. So hanggang 230 tayo. Ay, yes, 230. So okay pa tayo. Okay? So yun yung napalabas nating mga voltage across 4 ohms and across 8 ohm resistors. Actually, if you want, once we determine the voltage B1, B2, and B3, we can determine all of the voltage across each element here, including their current, if you want, including the power absorbed or delivered in each say element here. No? Power delivered by its source and the power absorbed by its element if you want. Okay. So the next technique here is by applying this mesh analysis technique. Again, this time using KBL. So this our given circuit. Our given circuit is in the steady state form, still in steady state form. So meaning we have to convert this element, including the active element, into phasor. So our W here is 2, cosine 2t, our W is 2t. So knowing that W equal to 2, then we can now convert this 2H into Z sub L, say positive J4, our 1 over 4 into negative J2 ohm. Actually, we try to consider the value of our Z sub here, say equal to negative J2. So meaning to say that the value of our C here is actually 1 over 8, not 1 over 4. Diba? Not 1 over 4, because the value of say sub C with respect to this solution here is negative J2. Otherwise, if we follow this 1 over 4, then we'll get Z sub C equal to negative J1 ohm. Since it is negative J2 ohm, so we can assume then that the value of each capacitor in the given circuit, not 1 over 4, but rather 1 over 8. So following that value of its capacitor there, we can simply say then that our Z sub is equal to negative J2. So using now the value of our Z sub is equal to J2 in our converted circuit, and at the same time, nag-assign tayo ng mga mesh current including their direction. So lahat ng mga direction ng current, mesh current natin here are all in a clockwise direction, starting from I1, this one, I2, this is the top part, and the right part here, I sub 3, I1, I2, I3 respectively, same direction. After doing that, we'll notice that by inspection, that our mesh current coincide the direction of our 2 angle 0 degree current. So meaning to say, the value of our I1 here is equal to positive 2 angle 0 degree. It is positive since the direction of our assumed mesh current I1 is the same as the direction of the given direction of our 2 angle 0 current here, source current here. Okay. Otherwise, if the direction of our I1 is against the direction of our, say, 2 angle 0 current source here, so we can simply say then that our I1 is equal to negative 2 angle 0, because they have the same direction, so we can simply say that I1 is positive 2 angle 0. Okay, and we also notice their source current here has no say element connected in series with it, just like our previous circuit diagram there. The voltage source has no element in series with it. That's why we can apply super node, right? In here, again, there's no element in series with this current source. So meaning to say, this time in here, we can apply the super mesh loop here. Okay. So we can apply we can use the super mesh around this circuit here, considering these two mesh currents, I2 and I3. So the current involved, the mesh current involved with respect to 10 angle 0 here are I2 and I sub 3, I sub 2 and I sub 3. So meaning to say, we can use super mesh around these two meshes current around this 10 angle 0 current source. So maybe we can start, if we try to consider the equation here, we can start here now, following this loop, super mesh loop. Yeah, so we have to follow this super mesh loop here. No, we call it super mesh loop, super mesh loop. So following this direction, starting from this 1 ohm resistor, then we'll have what? 1 multiplied by I3 minus I1. I3 minus I1 because our mesh current I3 coincide with this direction of our super mesh loop direction. So if that is the case, the voltage across this 1 ohm resistor then will be equal to 1 times I3 minus I1, not I1 minus I3, because I3 is the same direction of our super loop current here, super mesh current loop here. Okay, so I1 minus I3, then followed by this negative J2. There are two meshes current there, so we have I2 minus I3, I2 minus, I'm sorry, I2 minus I1, I2 minus I3, because I2 is in the same direction as the super loop current direction, a super loop direction, I mean. Then plus, followed by J4, I2, I2, without I1 or I3. Then plus I2 times 1, then followed by this 2 ohm resistor here, 2 times I3. There's no other current other than I3 here. Actually, this I1 is same as I3 here, right? Then followed by this negative J2 times I3. Okay, equal to 0. Okay, pwede na tayong bumalik dun sa starting point natin. From there, we can now equate it to 0. So simplifying, combining like terms, with respect to I3 first, we have this one. Then for I2, we have this. Then for I1, lahat transfer natin to the right side. Let's say, for example, this negative 1, we transfer to the right. And at the same time, this negative J2 times negative I1, positive 2J I1. If we transpose it, magiging negative J2 I1. Okay? Okay. Again, if you try to consider the technique in the solution here, we can simply say here that that the solution here is like this. Again, the current I1 was transferred to the right side because it is mentioned a while ago that the value of I1 is already known. By inspection, I1 equal to 2 angle 0. So we can simply say that this I1 here is 2 angle 0. No? Okay, we can directly substitute here for us to express our equation into two unknown only, say I3 and I2. Okay, from I3 to I2, I3 to I2. Yeah. Okay, substituting the value of I1 is equal to 2 angle 0 here, then we'll have this one. Or say this one. Na? 3 minus J I2, I3 times I3 plus 1 minus 1 plus J2, I'm sorry, times I2 equal to 2 minus J4, equation 2. So we need one more equation. So we can use this 10 angle 0 for us to determine the second equation. Following this 10 angle 0, at the same time with respect to mesh current I2 and I3, we can simply say by inspection that 10 angle 0 here is equal to I3 minus I2, not I2 minus I3, because the direction of our I3 is the same as the direction of our 10 here, 10 angle 0 here. So therefore, we can simply say that 10 angle 0 is I3 minus I2. I3 minus I2 equal to 10 angle 0, not I2 minus I1. Because the direction of our I2 is the same as the direction of the given current direction there. So and after that, we're gonna substitute the value of I2. We can eliminate I2 here since we're looking for the current in this 2 ohm resistor. And we know that the current I here is the same as this I sub 3, meaning I3 equal to I. So if that is the case, we can eliminate I2 here from this two equation. Tapos nakita natin na ang value ng I3 natin by following this technique here using matrix equation form. Then after that, using determinants, only to find out that the value of our polar form current I sub 3 is 5 angle 53.13 degrees. Since we know that this I3 is equal to I, and at the same time, we can now convert this phase or current I into its equivalent time domain, say I equal to 5 cosine 2t plus 53.13 degrees. So we have 28 minutes more. Okay, so the next theorem is superposition theorem. So in this superposition theorem, so kailangan natin kunin yung mga, let's say, corresponding components ng mga elements natin. Let's say, yung voltage or current sa bawat element natin. Let's say, for example, in here, we have three sources. So we need three components. Let's say, for example, we are looking for the voltage across 1 ohm resistor. We call it voltage visible. So meaning to say, if we apply this superposition, we need three solution, one voltage at a time. Now, as you notice here, the three voltage have different frequency. So we can only apply superposition. The other techniques cannot apply if they have different frequency. Only this superposition theorem na pwede nating i-apply dito kapag if we have different frequency. Pwede nating apply yung superposition theorem. Other theorem cannot be apply, no? If we have different, say, frequency. Okay. If we try to inspect a given frequency of each source here, say for example, for this sinusoid here, 10 cosine 2t. Omega here is 2. For the current here, for the sinusoid, the omega is 5. Then for the voltage here, the omega here is 0. While 0, because this 5 volt is a DC source, not an AC source. So meaning to say, if we have a DC source in this circuit, we can simply say that the omega of this 5 volt source is 0. Isn't it? Just like in your DC circuit, your omega there is actually 0. You have a 0 frequency in your DC circuit. But when it comes to AC circuits, we have, you can consider a different frequency in its, say, source here, in its source here. Okay. Okay. So for the solution, we try to consider the 5 volts first. No? Let the 5 volt acting alone. The remaining voltage then are converted into short circuit and open circuit. Why? If we have a DC source, sabi natin, yung mga voltage source natin are converted into short circuit, while yung current source natin are converted into open circuit. Let's say, for example, this 10 angle 2T is now represented by the short circuit, and this current source is represented by open circuit. The 2 ohm resistor here, just like our source voltage here, also represented by short circuit. Why? By formula, we know that the say sub L value of our 2 ohm here by formula is JWL. Since we are using 5 volts DC source here, we know that if we have a DC source, the omega here equal to 0, and if we follow the formula of Z sub L equal to J omega L, omega is 0, so meaning to say our Z sub L equal to 0. Meaning if it is 0, our inductor then will act as a short circuit, just like this here, just like this, short circuit, just like your voltage source here. They will act as a short circuit. Okay. How about this capacitor? The capacitor will act an open circuit. Why? Because by formula, a Z sub C is 1 over J omega Z. 1 over 0 is infinity. No? That infinity will correspond to infinity value of our Z sub C will correspond to open circuit. So our capacitor then will act as an open circuit while our inductor will act as a short circuit if we have a DC source. If we have a DC source, the inductor will act as a short circuit while the capacitor will act as an open circuit. Okay. Then after that, we can now consider the initial component of our original BO there. Let's say BO prime. That's BO prime, of course, will correspond to these 5 volts here. By inspection here, we can simply say that the sign of our voltage BO prime here is negative because if we try to consider the direction of our current here, it comes out from the positive there that enters the negative. Since it enters the negative sign of our B sub O here, we can simply say that our BO prime is negative. And at the same time, we can use voltage division principle here, say 5 times that 1 over the sum. So the answer is negative 1 volts. Okay. So we have to consider the proper yung proper yung tamang sign ng voltage natin. So yun. Kailangan ingatan natin yung paglalagay ng tamang sign. Tingnan natin yung direction ng natin current, no, from the given source. Okay. Tapos sumunod natin itong 10 cosine 2t. Tapos of course we're going to convert it to phasor. Converted phasor form of this 10 cosine 2t is 10 angle 0. So the remaining 2 voltage then will remove. We have to remove the remaining 2 voltage here. Say this one into open and this 5 volts into short circuit. So ito yung now corresponding circuit diagram natin. So the polarity is still positive, negative.